break. And it's our pleasure now to welcome Nancy Rebout to talk about tolerant and intolerant macaques differ in the context specificity of their cause and the form of their comments. So you can go on.
I can start. Okay. So the social complexity hypothesis for communicative complexity states that living in a complex social environment requires having complex communication systems. But the contrary can also be true, like having more complex communication system can also lead to the evolution of more complex social system. But the tricky part to test that hypothesis is to be able to measure complexity. So most of authors rely on numbers. So a complex social system should be a system with a high number of individuals. And the same goes for communication system, like vocal system. It's complex if it has a high number of signals. But these are rather crude proxies because it doesn't take into account, for example, interaction between elements. So what people agree on is that complex systems produce behaviors that are really difficult to predict. So beyond this, there is that idea of uncertainty. And to quantify uncertainty, there is Shannon's information theory that allows to quantify unpredictability. The more equiprobable, the more uncertain. So now where to find uncertainty in vocal communication? Maybe it's going to be in the link between acoustic structure and emission context. So here you have different acoustic structure. You also have different contexts. And if you have of this configuration, one acoustic structure is linked to one given context, so you don't face lots of uncertainty, because if you hear an acoustic structure, you already have the information about the context because of a direct link. But on the contrary, if you have more of this configuration, meaning one acoustic structure is linked to different emission contexts, you face a higher level of uncertainty, because even if you hear an acoustic structure, you can't deduce easily the emission context. And so in this link between acoustic structure and context emission, there is actually two options. So there is more uncertainty when acoustically similar calls are produced in different contexts. And it's what we call here context specificity. But you can also have that acoustically dissimilar calls are produced in the same social context. And that's why we went to study commenting calls. So commenting calls were first studied in Barbary macaques. It's the calls that are produced by a bystander of a social interaction, and the bystander is not involved in this social interaction. But we don't know about the structure of commenting calls. We don't know whether it has a specific structure. But if it has a specific structure, maybe it's a way to distantiate from the immediate context. So, okay, maybe physically I am in a given context, but maybe vocally I am in another one. So now that I got some direction to study vocal complexity, to be able to test the social complexity hypothesis, I also need to have social complexity. So to find species that differ in their level of uncertainty in their social interaction. And it's the macaque model is a good fit for this, because they share the same basic patterns of organization. So they live in multi-male, multi-female groups, where usually the males emigrate, although the female remains. So it leads to matrilinear structure. But they also show wide interspecific differences in social style. And actually, you have two extreme styles. In intolerant macaque, when a subdominated individual is threatened by a dominant one, usually what happens is that the subdominated individual is going to flee. So it's kind of black and white system. You know what is going to happen, and so they face a low degree of uncertainty. On the contrary, in tolerant macaques, when a subdominated individual is threatened by a dominant one, usually the subdominated one can flee, but it can also protest or even counterattack. And so in this system, you have way more options. And so individuals face a higher degree of uncertainty in their social interaction. So I compared 2 intolerant macaques, Japanese macaques and rhesus macaques, and also 2 tolerant species, Tonkan macaques and crested macaques. And so according to the social complexity hypothesis, I should find a higher level of vocal uncertainty in species with a higher level of uncertainty, meaning here, tolerant macaque. And to go further, in terms of context specificity of calls, I should find that the degree of overlap of acoustic structure with context should be more pronounced in tolerant species compared to intolerant species. And in terms of commenting calls, I should find higher degree of differentiation between commenting calls and calls usually emitted in the neutral context, so as a way to distantiate from the immediate context, and these intolerant species compared to intolerant species. To do that, I studied several individuals, so females, because they were the age-sex category the most represented. So I studied 2 groups of Japanese macaques, 2 groups of rhesus macaques, and 4 groups of Tonkan macaques. And these individuals were studied in captivity, and also 2 groups of crested macaques that were studied here in the wild. I used focal sampling, so I was able to get acoustic data and to draw spectrograms that have the evolution of the frequency as a function of the time. And I was able to take some measures such as duration, also energy quantiles, and also entropy, which is here a measure of the noise within the call. Based on some additional data, I was able to classify calls within 3 categories: agonistic, affiliative, and neutral. So agonistic, it was when the sender was involved in an agonistic interaction. Affiliative, it was when the sender was involved in an affiliative interaction, and neutral, when the sender was neither involved in an agonistic or an affiliative interaction. What about context specificity? So to study it, I used cluster analysis. So here in this layout, each dot corresponds to one call. And each color corresponds to a different context, affiliative, agonistic, or neutral. Each big circle corresponds to a cluster. So here I have set the number of clusters at 9. And the point of the clustering algorithm is to group together calls that are close from each other in terms of acoustic structure. And to study the link between acoustic structure and emission context, what I was looking at was the proportion of the different type of calls in the different cluster. And to do that, I use Shannon's entropy index. So here, for this configuration, it's quite tidy. So 1 color per cluster. If you had to calculate entropy, you will get a low entropy value that reflects here the strong association between structure and context. On the contrary, if you have more of this configuration, meaning which is more messy, you'd have lots of colors in the different clusters. If you have to calculate entropy value, you would get higher value that reflects the looser link between structure and context. So I did it for the 4 species using bootstrap procedures, and it's what I'm going to show you here. So here you have the evolution of entropy as a function of species. And what I show here is that tolerant species have higher entropy value compared to intolerant species, meaning either they use more similar structure in the different context, or that they use structure typical from one context in higher proportion in another context. So I don't know, maybe agonistic calls that are more specific from agonistic context, but also used in the affiliative context. But in any case, it leads to more uncertainty in their vocal communication. So here, a looser link between structure and context, it finally indicates a richer communication and also the potential to transmit more information and also the potential to have more expressiveness. So in intolerant macaques, we have less expressivity, and it can be relevant because they face quite straightforward social interaction. But on the contrary, in tolerant species, because they face higher degree of uncertainty in their social interaction, having more expressivity can help them to increase their negotiation skills and also aid them to manage their open contests. What about commenting calls? So commenting calls, I described it as call emitted by a sender, which is not involved in a social interaction, but a social interaction happened within the first second it was vocalizing. And I was comparing the structure of these commenting calls to calls emitting during interaction, and also to the structure of calls using during the neutral context in general in the absence of interaction that we called uncontextualized call. I couldn't do it for Japanese macaques because I had less information at the triadic level. So here, what you see, it's a visualization of a PCH was just for illustration purpose. And here a tree that just allow you to see the results of the permanova and to see what is significant and what is not. So if we, for rhesus macaque, commenting calls did not significantly differ from uncontextualized calls, meaning they do not have a priori another information, a specific information compares to uncontextualized calls, but they significantly differ from interaction calls. In Tonkan macaques, it was not the same, commenting calls significantly differ from uncontextualized calls, meaning a priori they had another information, and maybe that information is linked to the interaction call because it's what the results in Kristen macaque suggest, because interaction calls and commenting calls do not significantly differ. So the study of commenting calls brought another dimension of the study between acoustic structure and emission context. And so maybe it's a way for them to distantiate. It's an ability to distantiate from immediate context and to communicate as first party about group mates interaction. It also reflects a greater freedom of expression. In intolerant macaque, we didn't find visibility, but maybe it's relevant because if the result of social interaction is predictable, maybe there is less need to give a specific information. On the contrary, in tolerant macaques, because their social interaction are predictable, it might be beneficial to inform the group and maybe also to express emotional response about interaction that are happening right now. And it's consistent with what we know about tolerant species because they show a stronger commitment to the behaviors of others. Of the state, they are more socially involved. So, in terms of social complexity hypothesis, because I found higher uncertainty in vocal communication in terms of context specificity and also form of commenting calls in tolerant species compared to intolerant species, tolerant species that faced the more uncertainty in their social interaction, I was able to find a correlation between uncertainty in social interaction and uncertainty in vocal communication, which is finally a correlation between vocal complexity and also social complexity. But maybe there was a confounding factor in phylogeny, because in one side, Japanese and rhesus macaque in one side, and Tonkan and crested macaques in the other side, they belong to two different macaque lineages. So one may wonder whether this could have affected the results. In another paper, we discussed it, and we show that other results could not be explained by the phylogeny itself, although the social complexity hypothesis could. But of course, these results, future research should extend the comparison to a higher number of species and also groups to to confirm these results. I thank you for your attention.
Thanks a lot for your great talk. While the chat writes its question, we can maybe try by a very naive one to kick things off. Do you think, well, the acoustic environment of captive animals as compared to wild animals, do you see the sound landscape differs a lot and then alters the way the individuals interact?
Yeah, I see. But the thing is that here, for example, if you take rhesus macaques, they show the same kind of repertoire, although there are the species that live in the forest and also outside of it. So they show high diversity of environment, and although their communicative signals do not change over it. So, and yeah, it could have happened, but the results show that it does not.
Thanks. Seems the chat is a bit shy now. We have.
Don't be shy.
New question. Oh, Natasha was asking, for the species, what's the advantage of having a complex communication system?
Yeah, I guess when we talk about complexity, at the same time, there is that notion that, oh, it's going to be hard. But at the same time, it's also more richness. So it can allow to express more emotion, more shades in their communication, and so to be able to, for example, negotiate and to have more subtle social interaction at the end. So it's, yeah.
Yes, thanks. We have a question from Abby George, who says, great talk. Maybe I missed this, but it was not clear to me what you meant by greater uncertainty in social interactions within tolerant species.
Yeah, it's the fact that in tolerant species, when interaction occur, there is lots of options that can happen, and it's not black and white. It's not like a dominant individual is threatening a dominating one. It's like they can have coalition. They can also in intolerant macaques, but in lower proportion. So it's like you can't decide, and if you are an observer, you can't like guess what is going to happen. You have to watch it.
Thank you. Another question from Sebastian Minoli. Vocal communication capacity is innate and species specific, but language contains a big amount of social learning. Did you consider the relevance of learning in the complexity?
Yeah, I was not on that that level because I was studying adult females, but I'm sure that there is a lot of research to do in that topic to see in the level of uncertainty maybe in the learning, in the communication. I mean, it could be great.
Mm-hmm. I guess in the same line about future work, Daniel Galliano is asking, do you plan to include more species in your analysis? And if yes, which species would you include?
Yeah, what I would have loved to is to have like intermediate social style, because here I have the two opposite, like tolerant and intolerant macaques. But actually there are 4 grades going from intolerant to tolerant. So it could have been nice to see what happens in the middle. If we can see like a linear effect or maybe not. So.
Thank you. Do we have other questions in the chat? Maybe not. So I guess for now, that's all. Thanks a lot for your talk. And if the chat has new questions, I'm sure they can ask them in Discord, and you'll be happy to.
Yeah, I will.
There. Okay. So thank you a lot for
Bye.
the very nice talk.